Hi, in the previous section, I have generated a project called path.zip under light example 4G lambda folder. This is the project we generated. The latest code I'm gonna check in, so there are a little bit upgrade in the version as well as the Gradle jar file. So for this video, I'm gonna walk you through the scaffolded project in the editor. Within the editor, I'm gonna go to the directory called the light example 4G. Here we go. And within this, we have a lambda folder, and the newly scaffolded project is in the path.zip folder. So in this folder, we have multiple directories. The first directory, events. You can see for every lambda function, we have a JSON file defined event. So you can use this event to test the lambda function locally when we run the lambda function within the Docker image. So this gives us a chance that when we update our business logic, we can use this event to access the lambda function to do the local test within the Docker. We don't need to deploy this to the AWS in order to test the lambda function. This can be tested locally with the Docker image. There are 4 different events, like for the 4 different endpoints, because we have get endpoint, we have delete, and the post endpoint. For every different endpoint, we have a different generated event. So this one you can see the HTTP method is a post. We have then it's matched to this lambda function. Yeah, along with all the testing events, we have 4 different folders for the lambda function itself. So let's walk through one lambda function we generated. This is the first one we generated. This is a path get function. Within the function, we have the Gradle folder with a wrapper, so that you can build this without install or download Gradle for the Java command line. Also, we have the source code and the test cases. So within the source code, you can see this is the lambda function we generated. We have this app.java, that's the entry point. You don't need to do any update for this file. This is basically the entry point from our lambda framework. Every time a new request coming in, it goes to the app. So the app will basically say you have this request API gateway proxy request event and a contact passing, and after that we log it, and we also just run the interceptor request for the request side middleware handlers to do the verification, validation, tracing, matrix, all kind of cracking concerns on the request side. And after that, if we have something returned from the middleware handlers, one of the middleware handler, then we basically say return this as error. For example, the validation fails, we return the validation error. If nothing returns, that meaning we pass all the middleware handlers, all the process is done on the request pass. Then we created the business handler, and after that we call the business handler, passing in the input and the contact. This input and the contact will probably be enriched by the request side interceptor already with some of the middleware handlers. And after we got a return value from the business handler, we apply we intercept the response to apply all the cracking concerns on the response side. For example, calculate the matrix, handle the exceptions, things like that. For example, the matrix calculation, we need to record when we invoke the lambda and when we get the lambda response. So that has to be captured in 2 different phases, on the request side and on the response side. So this is the entry point. We don't need to do any modification for developers. For developer, the only file they need to change actually is this business handler. So the business handler is very simple. We scaffolded this based on the OpenAPI specification. In the OpenAPI specification, we have examples. So we just basically output the example here. That's the constructed from OpenAPI YAML. So if you look at how we do this, we first get a header. In the handle request, we have the input, we have the contact. We first create a header and put this content type application JSON, and after that we create this response API gateway proxy response event. This response event, we put a header in, so we know the response we have content is application/JSON, and after that we create this output string. We create a response code, status code with 200, and after that, with the body, it's output this string, and then we return the response. This response actually is API gateway proxy response event. This response then will be applied for all the middleware handlers on the response chain, and after that return to the API gateway or another Lambda function, depending on the request. It's coming from it's an external request or internal, like Lambda to Lambda invocation. We also have model generated CPath and the arrow from the specification. Within this generate Lambda function, we also have, along with source code, we have test cases generated as well. So you can see we have this test, and we also have this business handler test. So you can always create a test case for your business handler, run this to ensure your business logic is correct. We also, in this folder, we also have some resource generated as well. So this is the app.yaml, which is a configuration for the Lambda function. You can have configuration per stage, like dev, sit, stage, and the product. And here we are using the product trust store and the password for the trust store for the TLS connection. Logback.sml is used for our login configuration. We also have OpenAPI YAML in this folder. So this is exactly the OpenAPI specification I showed you in the previous section. So we are using this OpenAPI specification to do the validation. The validation rules defined in the spec. We also use this specification for the security validation for the scopes. If you look at this spec, for every endpoint, you have this security definition with a scope, read, pass, something like this. So we need to make sure, like the GW token pass through, we need to verify the scope so that we know if the request has write access to the particular endpoint or not. This is a product PRD trust store, which is it contains the certificates so that you can connect to the OR server to get the JWK. So this is the for one Lambda function. All other Lambda functions should be similar. In the test folder, actually, there's some other configuration as well for testing. This is a test logback test XML. Yeah, this is the Lambda function itself. We have 4 different Lambda functions because we have 4 different endpoints. We also generate the ignore file and the README. If you look at the README is very detailed document on how you're gonna use this to do the deployment. And you can see we have this folder is introduction, and this is the template YAML, and public VPC or private VPC is used when we have the proxy approach. In our current scaffold project, we are using pure Lambda solution, so there are no VPC configuration. And you can see describe stack, how we're gonna use the command line. This is AWS command line. and delete the stack, deploy and deploy the proxy, things like that. Deploy the sample application, how we do the deployment. You can see how we do the build. So we can use same build and same deploy dash guided. This is how you use to test local. You can using this event to test locally using the Docker container. And this is how you using the same local start API to start the Lambda function locally. And resource to your application, fetch, tail, the logs, unit test, clean up, resource. So this README contains a lot of useful information, so please read it and to see how this is supposed to be working. The other most important file we generated is the template YAML. The template YAML is the central piece how we deploy the Lambda function to the AWS as a service, as a Lambda function service or services. So within this file, we generate the API gateway. This is the gateway configuration. You can see for the gateway, we have the stage as a product. That's why in the configuration, we use the product as a section to configure the TLS certificates. Yeah, and within this gateway, we have OpenAPI 3.0 definition. This definition extracted from the OpenAPI YAML we used to generate this project. So you can see we have 4 different endpoints. Each endpoint is mapped to a Lambda function using the ARN. So you can see here is the ARN for different Lambda functions. That's the specification piece. And for each Lambda function, we have a section. This section contains the code URI. It also has handler, which handler we're going to invoke. And this is, as you know, like when we generate this app.java. Within the app.java, we have a method called handle request. This is always the entry point for the Lambda function, for each Lambda function. The runtime is provided because we are using customized runtime so that we can use a Grail VM to build a native image. The memory size, the function name, this is the name of the function, and the environment variables. We don't have environment variables, but there is a placeholder. You can add environment variable. We also have this section like for the events definition. So for this endpoint, we have the path. This is the OpenAPI path, and this is OpenAPI method. Also, we have the REST API ID reference to the API gateway we defined here. This is the reference to the API gateway we defined. So all of them, like there are 4 different Lambda functions. The last one, we have authorizer definition here. This is the permission, how we define the permission, how to access the Lambda function, and from the API gateway. So you can see it depends on the API gateway, which is defined in the beginning. Also, we have this invocation, invoke function for permission. We got this is the function name is called authorizer. This authorizer is the one we deployed to the API gateway to verify the JWT token signature. Yeah, this is the principal, and this is the source ARN. Yeah, that's it. This is the file. Basically, like it's a central piece how for our newly scaffold project. So using this file, we can build the Lambda functions, and we can also deploy this to the AWS. So in the next step, I'm going to build the project and then prepare it to deploy to the AWS hosting service. Yeah, that's it. Thanks. Bye-bye.